In the realm of industrial automation, devices known as drives or frequency converters play a crucial role. These components are essential for regulating the speed, torque, and position of electric motors in various machinery and production systems. By fine-tuning these parameters, manufacturers can enhance energy efficiency, achieve precise motion control, and adapt their equipment to the dynamic requirements of different processes. Imagine a factory floor where every machine operates in harmony, adjusting its performance based on real-time needs. This is where drives come into play, ensuring that motors run efficiently and accurately. But there's more to the story. A recent development in this field is the introduction of a new type of drive that supports multi-protocol Ethernet communication. This advancement allows for greater flexibility and integration within industrial networks. Ethernet-based drives can communicate using multiple protocols, making them compatible with a wide range of systems and devices. This capability is particularly beneficial in environments where different machines and control systems need to work together seamlessly. Discover how multi-protocol Ethernet drives revolutionize industrial automation as we delve deeper into their functions and benefits. Now, let's delve into the core mechanism of multi-protocol Ethernet drives. Imagine a drive as a sophisticated translator, capable of interpreting and communicating in multiple languages or protocols within an industrial network. This drive operates by converting electrical power into mechanical motion, adjusting the frequency of the electrical supply to control the motor's speed and torque. The multi-protocol capability allows it to interface with various systems, regardless of the communication protocol they use. This means you can integrate new machines into your existing setup without worrying about compatibility issues. Furthermore, these drives offer enhanced monitoring and diagnostics, enabling operators to collect real-time data and perform proactive maintenance. This leads to improved reliability and reduced downtime, as potential issues can be identified and addressed before they cause significant disruptions. To start configuring your multi-protocol Ethernet drive, you'll need to access the drive's configuration menu. Begin by setting the communication parameters. Set the IP address to a static value within your network range, for instance, 192, 168, 100. Ensure the subnet mask is 255, 255, 255, 0. Next, configure the baud rate to 19,200 for optimal compatibility with legacy devices. For protocol selection, enable Modbus TCP, Profinet, and EtherCAT. This ensures maximum flexibility for your industrial network. Remember to set the timeout parameter to 500 milliseconds to avoid communication delays. Once these settings are in place, save the configuration and reboot the drive to apply the changes. This initial setup is crucial for seamless integration into your automation system. Now, let's delve into the execution process and communication methods of multi-protocol drives. These drives operate by receiving commands from a control system and translating them into actions that regulate motor speed, torque, and position. The execution process involves several steps. First, the drive receives a command via one of its supported protocols. Next, it interprets this command and adjusts the motor parameters accordingly. This is where the multi-protocol capability shines, as the drive can receive commands from various sources, regardless of the protocol used. For instance, it might receive a Modbus command from one device and a Profinet command from another, all while operating seamlessly. The communication methods are equally important. Multi-protocol drives use a combination of standard Ethernet frames and protocol-specific data to ensure reliable and efficient communication. This means that the drive can handle high data rates and low latency, crucial for real-time control applications. Additionally, these drives often include built-in diagnostics and monitoring features, allowing operators to track performance and troubleshoot issues remotely. This level of integration and flexibility is what sets multi-protocol Ethernet drives apart in industrial automation. Now, let's dive into advanced optimization techniques for multi-protocol Ethernet drives. First, consider parameter tuning. Set the deadband parameter to 0.5% for smoother operation, Next, for edge cases, if you encounter latency issues, adjust the polling interval to 50 milliseconds. This reduces response time significantly. Additionally, if you face compatibility issues between protocols, ensure the protocol priority is correctly configured. Set Ethernet/IP as the primary protocol and Modbus as secondary. Lastly, for troubleshooting, if you see error code 1204, it indicates a communication timeout. Check your network settings and ensure the drive's IP address is correctly assigned. Remember, these tweaks can dramatically enhance performance and reliability. To wrap up our deep dive into multi-protocol Ethernet drives, let's address some common pitfalls and summarize the key takeaways. One frequent mistake is underestimating the importance of proper configuration. Always ensure your drive's communication settings match your network's requirements. Another pitfall is ignoring the need for regular firmware updates. Manufacturers often release updates that enhance functionality and security, so stay informed. Lastly, don't overlook the value of thorough testing before full deployment. This ensures compatibility and performance across your system. Remember, these drives offer unparalleled flexibility and integration capabilities, making them a game changer in industrial automation. By mastering their use, you'll significantly enhance your system's efficiency and reliability. If you found this information valuable, consider subscribing for more in-depth, free education on cutting-edge technologies.